So basically, a programming language is instructions or commands. Instructions. Instructions. Instructions or commands that we give that a computer can understand and execute. So when you talk about programming languages, of course, there are very many programming languages, and based on what you are doing, uh, uh, um, whatever you are doing is what will determine the programming language you choose. So, for example, in this case, we are learning Python. That is because we are doing either data science or data engineering, and Python is one of the languages that is known for data science. I think it's Python and R and maybe some other languages, but Python is the most common one. So that is why we are learning Python. But again, that does not mean Python is not applicable in other areas. Um, Python is very versatile. I think it's also used in web development. So in web development, when you learn about frameworks like Django, Django is a web framework. But of course, these are things that we'll not look at here because we are not learning web development. But just for general knowledge, we have frameworks like Django. We have another one called Flask. And then there's the latest one, which is Fast API. So these are web frameworks. Python is also used in, so this is in web development. And then Python is also used in game development. Um, in game development, web development, of course, data science. What else? Um, and very many other things. Okay, automation, and all that. So all these are applications of Python. But of course, Python is a programming language. It's a high-level programming language. So a high-level programming, we have low-level programming languages, and we also have high-level uh, programming languages. So what makes a language low level? A low level language is a language that easily interacts with the computer hardware, right? So when we talk about the assembly language basically, um, okay, humans can understand it, but it's very low level. It's basically like instructions that you give to the hardware of a computer that the hardware is able to process very fast. High level tends to be more human readable, all right? So that is why we say Python is high level language, because basically you can easily read and understand the syntax of Python, all right? Computers might take a bit of time, but of course computers are very fast, so they are able to convert the high level language, that is the human readable language, into bytes and later into binary that computers can understand. So Python is a high level language. um, it's an interpreted language also. So when we say a language is an interpreted language, there are various ways in which the codes you write in a language are executed by computers. We have compiled languages, and then we also have interpreted languages. Most of these high-level languages tend to be interpreted. So to interpret, basically, it means the compiler, which is what converts the human written code into into instructions or into bytes that the hardware can understand. The interpreter in this case basically reads the human written code line by line and executes them like that. But a compiled language, the compiler basically uh, reads the entire code. So if it's a file, it will read the entire file, compiles the entire file instead of going line by line. So that's the difference between an interpreted language and a compiled language. So those are features of Python. It's an interpreted, it's a high level language. You can also say Python is flexible. So you can add flexibility here. So flexibility in terms of what? So Python supports both uh, OOP and also functional programming. So OOP is object-oriented programming. So these are programming paradigms. Okay, these object-oriented and functional programming. So functional programming is the most common one, um, where basically you write your code in function form. So basically, you just have very many functions, and then they call each other and interact with each other for the program to run. And then object-oriented, basically, it classifies things into classes, and then these classes have properties or attributes. So a class can have attributes like methods. It can have variables and all that. So, but basically we look at that in details when we talk about classes and object-oriented programming in general. Another property of Python is you can say maybe readability and simplicity. Python is very simple and can be easily read compared to other languages. For example, if you were to compare Python and Java, Python is very simple to write. By just one line of code, you are able to print something to the console compared to when you're writing in Java. Okay, we normally say Java is verbose. Verbose means uh, you have to write very many lines of code for for the program to give you maybe an output. So, for example, in Python, you just write print and then you can say hello world inside the print and then it will just print hello world. But in Java, if you are to print hello world, you probably need like 5 lines of code or something, right? So that's what makes Python stand out. Python also has a large community. So when we talk about community, basically we are referring to the contributors and the people who use Python generally. So yeah, that is what we refer to as a community. So it means there are a lot of people worldwide who are using Python. So it makes it easy if you're facing a problem or a bug in your code, you can easily post it to any Python forum and it can get resolved very fast. So with that, basically we've talked about programming, we've talked about Python in general, application, of course, we've mentioned web development, data science, automation, game development, and very many other things. Uh, but then if you're not aware, you know, backend of YouTube, the platform we use is actually built in Django. So that is also Python basically running there. So that is that in Python in general and programming. This is not too complicated, but one thing we can talk about here is basically installation. How do you install Python? So this is based on the operating system you're using. So for example, if you're using Windows, you just need to go to your browser and then you can just search for Python. Uh, you can have it here, the first link, and then you can come to downloads. So downloads here, you can basically download any version of Python. So you can see all the versions we have here. So 3.14, I think, is the latest version. We have also 3.15, which is a pre-release. So this is still not stable. So it means if you download 3.15, you might encounter some bugs here and there. But 3.14 is a bit more stable. And you can see here the button here, download Python installer manager or get the standalone installer for Python 3.14. So you can see you can download Python 3.140 there. Uh, if um, if you are an advanced person, you can actually go on and download 3.15 uh, and then you can always contribute or whatever, fix the bugs and all that. So that is how you download Python. For people who have um, um, MacBooks, I don't know how to download Python on a MacBook. I've never done that. But basically, I know most of us use Windows, so this is the simplest way. You simply just download the installer, you run it, and then you can confirm the version on the terminal. So when you open your terminal and you type Python dash dash version, you see this one is 3.14.0. So that's the Python version that's running in this particular computer. Now, there are various ways of running Python or executing Python code. So, for example, after you've installed Python like this, you can decide to install or download and install an IDE. IDE is an integrated development environment. So you can download and run Python there, or you can run Python on notebooks. Like I think in this course, we've been introduced to Notebook and Google Colab, which are also Python platforms. So the good thing about that is that you don't have to do any installation. For example, on Google Colab, you don't have to install Python. It comes with Python already pre-installed and configured for you. If you download an IDE, I think the Python IDE is it's called PyCharm, I think. Yes, PyCharm. So you can download and install PyCharm, and then you can run your codes there. This is also okay. It's good. If you have VS Code, you can also use that. That is the text editor. You can also run Python on Python shell. So basically, if you open any terminal, as long as you have Python installed. So for example, in this case, if I just type Python and then I press enter, it opens the Python shell. Okay, so you can see here Python 3.14, blah, 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 a lot of things there. So this is the Python shell. You can see these three greater than signs. So it means from here, I can actually write any Python code and execute. For example, if I say print uh, hello world and then press enter, you see it prints hello world. You can create variables. You can say name equals to Velma, and then you can also say age. Velma, how old are you? 12. And then you can say print format. You can say my name is his name, and I am years old. If you press enter, you see you can execute Python codes on the Python shell here. So this one is my name is Velma and I'm 12 years old. To exit this, you simply press Control and D, and then you come back to the normal terminal, right? So those are the three, the main ways in which you can access Python, right? Okay, so that's that. Now, let's go to the next thing, which is variables and data types. So, when we are coding or when you are programming, basically, you are dealing with information or data. So it means you need to be able to store this information, manipulate it, and all that. So that's why we have to understand what variables are. So in short, a variable is like a container that stores a value in your computer's memory. Uh, Variable, you can say it's a container that stores a value or data in your computer's memory, in the computer's memory. Okay. So for example, if I say age equals to 12, okay, age in this case is a variable. Okay, the variable is called age. So this is the variable name. So you can say age here is the variable name, and then this equal sign is an assignment operator. In programming, uh, or in Python, you can say this is not an equal sign. Equal sign in programming is two equals like this. This means equal, okay, strictly equal. If you use one equal sign, it's an assignment operator. It means you are assigning a value to something, okay? And then this 12 here is the value, okay? So it means we are creating a memory address, and then we are giving it a name of age, right? And then this name here, we are assigning a value of 12 to it, okay? So the age is the variable name, this equal sign is an assignment operator, and then 12 is the value, right? So this is how you create variables, okay? So variable, basically the age is the store, it stores an integer, uh, uh, and then you can have different types of variables. So for example, age in this case, this is an integer variable, okay? 12 is an integer number, right? We can have name, and then we say Velma. So in this case, the variable is called name, and then we are assigning a value of Velma to it. So this is a string, right? So we are assigning a string data type to the variable name. Okay. This is basically how you define a variable. You just write the variable name, then an equal sign, and the value, right? Now, the good thing with Python is that it automatically knows what type of data it's storing. Some programming languages, if you are creating variables, you have to specify the data type. For example, in Java, if you want to create a variable age, you have to say int age, and then you assign a value of it. Yeah, you assign a value to it. So this tells the compiler that you're creating an integer data type called age, and then you're assigning a value of 12 to it. But with Python, you don't have to specify this int here. Python automatically is able to detect the value that you pass here. Okay, so it will see that this is 12, and then it's able to detect that this is an integer. So age will basically store an integer. Okay, now we have variable naming rules or conventions. How do you name variables in Python? They normally say variables must start with either a letter or underscore. Okay, for example, this variable age, you created a variable age, and then we assign it the value of 12. You see, it starts with a letter. Okay, it's not supposed to start with a number. For example, you say to age like this. This is wrong. Okay, this will probably throw an error. I think let's test it. So we have a variable age, and then we assign it a value of 12, and then we print age. It prints 12, right? Now, what if our variable name starts with a number? You see, already that number is highlighted there. So if you press enter, already there's a syntax error. It throws a syntax error, invalid decimal return, right? So the compiler will not allow you, okay? It throws an error. Now, variable names can also contain letters, numbers, and underscore, okay? Can contain letters, numbers, and underscore. For example, you can say age underscore 1, and then you can say maybe 14. Okay, so they can contain letters, numbers, and underscore, as long as the name is descriptive. Okay, maybe you have 10 ages of different people, so you can say age 1, age 2, age 3, up to age 10, like that. Okay, now variables in Python are also case sensitive. For example, if you say age and age, these are two variable names. Okay, this one starts with capital letter, this one starts with a small letter. So there's a difference in that. They'll be stored in different locations unless maybe the values are the same. Another rule is when you're naming variables, you're not supposed to use Python keywords. Do not use Python keywords. So what are Python keywords? Things like def, um, things like maybe you can say break, and all that. So keywords basically are those um, how can I describe it? Like pre-built words. Uh, they form like the part of the Python language. For example, def here is used when you are defining a function. Okay, so if you create a variable called def like this, and then you give it a value of 12 or 10, then this will throw an error. Okay, because the compiler will assume that you're trying to create a function, but then it sees an assignment operator here and another value here, so it will throw an error. It does not understand what you're trying to do here, right? Now, sometimes we normally say that Python is dynamically typed. What is a dynamically typed language? Okay, so a dynamically typed language is a language that you don't need to declare the type of variable when you are creating it. Okay, uh, for example, we created age and then we assigned it a value of 12. We did not specify the data type. Okay, that is why we say Python is dynamically typed. The languages where that requires you to specify the data type when you are creating the variable are not dynamically typed. Okay, so that's just about the way that you need to understand. Now, we've learned how to create variables, but when you're creating variables, you need to assign them values. Okay, so these values have to be of different data types. Okay, so we have to understand the different data types in Python. The first one that I've already talked about and mentioned are integers. Okay, so integers, they basically store whole numbers. They store whole numbers, and these whole numbers can be either positive or negative. Okay, for example, you can have 10, you can have -7, you can have 0. All these are basically whole numbers, right? You can have 1000 and all that. So those are integers. Okay, we also have float. So float basically store floating point or decimal numbers. Okay, they store decimal numbers. For example, you can have 9.9, you can have 80.9, whatever. All these are called float, decimal number. Any number that has decimal point is a floating point number. We also have string. So string are basically a sequence of characters, or you can say very many characters that are put together. They are normally put in quotation marks. It can be double quotes like hello, or it can be single quotes, right? This is what tells the Python compiler that this is a string. So you can have it in single quotes or in double quotes like this. That is string data type. We also have yeah, Boolean. So bool. So these ones they represent truth values, and they can only be two. It can either be true or it can be false. That is Boolean. Any other one that I'm missing here? There's also another one called non-type, by the way. Non-type. Non-type, they represent, you can say they represent nothing values. They represent nothing values. I think the most common one is none. None. Okay. Sometimes you can always check the type of the type of data using the type built-in function. So, for example, if I create a variable age and I give it a value of 30, I can, let's say, print and then type age like this. If you press enter, it prints class int. So it means this variable age belongs to the Python class of integer, right? So it's an integer data type. If I say name equals to Victor, and then I print type name, you see str, it's a string, right? It's a string data type. So you can use the type function to check the data type of your variables. Okay, to exhaust this part of variables in data types, we also need to understand what we call type conversion or casting. Sometimes you may need to convert data from one type to another. So, for example, let's say you are collecting data from people. Maybe you have an online platform which you use to collect maybe data or information, or it can be a login page. So, or a sign up page. So maybe there's a section where people are supposed to insert their age and all that, right? Now, most of the time, if you're collecting data through forms, the data that is collected, because you're talking basically about the web mostly understands JSON data types, so which are basically in string formats. So you can find uh, when the data comes to your end, it can have age of maybe 20 like this. It's a string, okay? It's a string, but you know very well that age is supposed to be an integer. So you would want to convert this data back into an integer so that you can manipulate it and do whatever it is you wanted to do with it. Currently, if we print a type of age, it's a string, right? It's a string, but we want it to be an integer. Maybe we can create another variable here. We can say new age, and then we say int age like this. So it means we want to convert this age into an integer. So enter, and then now if we print now the type of new age, you see now it's an integer. All right. Or you can just convert age here directly. You can just say age because you can reassign it. Age is equals to like that. And then now if you print type of age, again it's an integer, right? So we are basically converting it from a string to an integer, right? Now, sometimes you need to be careful because, for example, if you have a name like this and then you say name is Velma, there is no way in the world this will become an integer. Okay, this one can never become an integer. So if you try to say name equals to int and then pass it name like this, it will give you an error, a value error. Okay, invalid resolve for int with base 10. Okay, so this is a string. There's no way you can ever convert it into a base 10 number. Okay, so that is that on data types, and variables in general. What you need to understand is that variables are just containers that store values in your computer's memory. Okay. The moment you create a variable, for example, you say name like this, it goes to the computer memory and then it creates a space based on the type of data, right? For example, I think integers cover like 8 bytes. Is it 8 bytes or bits? I think 8 bytes. Um, so it means when you say 8 bytes, it means when you say age equals to 12, it will go to the computer memory and allocate 8 bytes of space. All right. So whether this value 12 is there or not, it will allocate that space so that when you provide this value 12, 12 will be stored there. Okay. When you talk about bytes, now this is why I tell you that computers, they don't understand the language we are talking. They understand binary. Okay. So it means this 12 will have to be converted into its binary format, and then each of the bits will be stored in each and every slot within these 8 bytes of memory that has been created, right? So that is how it is. If it's a string, I don't know, string occupies word space. Character is 1 byte, I think. So if it's a string of maybe 10 characters, I'm assuming it probably will be like 10 bytes or something. Okay, but that is basically how computers are able to store the information. Okay. Any question up to there before at least I continue? Velma, is there any question?
I don't think so, unless there's someone who I think people are good. Yeah. Yes, they
Okay,
are.
okay, okay. Now, there's some basic operations that we can perform on with strings or maybe numbers. So, for example, you can have thing, let's say maybe basic operations with strings and numbers. So, operations can be maybe like we can have addition, we can have subtraction, basically the arithmetic operations, addition, subtraction, multiplication, and all that. So when you talk about strings, basically addition in this case means you can combine more than uh, uh, one string. For example, let's say we have um, yeah, you can have like first name. First name is uh, okay, Velma. I'm gonna use your name a lot here, Velma, and then last name is like that. Okay. You want to combine these two so that you can have full name, right? You see, you can't just say Velma Saka, or you can just say first name, maybe comma, last name. Okay. This does not make sense. So, to combine strings, you can use the I don't want to use addition. Okay, but you can use the addition symbol. That is the plus. Okay. So what you do is you have the full name here, and then okay, let's just do it here. Oh, sorry, let's clear it again. Yeah. So we have first name, then if I spell that right, then we have last name like that. So we want to get the full name. So for full name, we have to combine the first name and also the last name. So we can say, if I spell that right, first name plus, let's say we want to have space here, and then another plus, and then this is last name, like this. So that if we print full name, we get Velma Saka. So we have first name plus, and then space, and then because this is also a string, okay? So we're going to have this string of first name, and then we're going to have space, and then we're going to have last name. That is what we have here. So we have the first name, then we have space, and then we have the last name. Okay. So this is how you can combine strings in Python. What if you want to repeat a string maybe certain number of times? Okay. For example, you want to print hello world maybe 3 times. Okay. So to print that, you can say maybe print. We have the string like hello world, but we want to print it maybe 3 times. So you use the multiplication symbol like that. So we have hello world. If you press enter, you see it prints hello world, hello world, hello. Maybe we can print it. Let's have each and every one on its own line. So if you put new line like that, then press enter. So it prints hello world, hello world, hello world. It prints it 3 times. So it's basically it's like you're saying hello world times 3. Okay. This is this the backslash or forward slash? I don't know what this is, but that stroke and then n means new line, right? So that one prints it 3 times. If you put it here maybe 9 times, then of course it will print hello world 9 times, right? So that is to print strings multiple times. What if you want to access characters of a string? For example, we have the word hello. Okay. So of course we know this is 1, 2, 3, 4, 5. It's 5 characters, but what if you want to access each and every character of this string? So again, we use index or indices. So for example, if we say print and then we want to print word at index 0, it will print h. So the first index, indexing in programming starts from 0. So 0 is the first index. So, and then 1 and then 2 like that. So your h is at index 0, e is at index 1 like that, like that. So if we are to print um, index 4, let's see if index 4 is there, it prints O. So remember we said this, yeah, there are 5 characters here. So 1, 2, 3, 4, 5. O is the last character. So it's at index 4 because we started counting from 0. So H is 0, E is 1, L is 2, another L is 3, and then O is at index 4. Sometimes if you want to get the last character, you don't need to count and then know the number of characters, because if it's a whole sentence or paragraph, you'll not be able to. It doesn't make sense trying to count each and every character within the entire paragraph to get the last index. So to print the last index, you can just say print and then um, word and then -1 like this. Okay, so -1. Basically, okay, with indexing, when you're moving from left to right, it starts from 0. And then if you want the last character, that is O here, coming and moving to the left, that is from right to left, you start at -1. So it means O is -1. This the second L here, the second last L is -2, like that, like that. So for example, if I print this, we get an O. All right. If I put here -2, you get an L. All right. Let's see, if I put -4, we get an E. So this is -1, -2, -3, -4. E is at -4. So if you want to get uh, the the first character this way, you have to print -5, and then you get H. So it means here we are starting from right, moving to the left. But if we start from left going to the right, we start with 0. Sometimes you can do what we call slicing. So slicing is basically extracting a part of a string from maybe a sentence or a word. So for example, if we print um, word, and then you can say 0 to 3. Okay, press enter. It prints HEL, hell. Okay, so it will take the first index. It will take the word at, yeah, the character at index 0, the character at index 1, and the character at index 2. Those are 3 because we want 3. Okay, 3 minus 0 is 3. So we want 3 characters only. It will include the first character but not the last. All right, because it's counting. Okay, so it will count 0, 1, 2. Those are 3 characters. 3 minus 0 is 3. So it will only print that one. If you want to get the proper spelling of hell here, then we'll have to make this 4, right? So you'll get the 2 double L's like that. Okay. Sometimes you can do like this. Let's see. Let's print maybe 2, and then like this. So when you print 2 and then the colon, it starts from the right moving to the left. So it will count 0, 1, 2 up to index 2. So the second L is at index 2. Okay. Um, if you put the semicolon before the number, now it's the other way around. It starts from the left moving to the right, and it will pick exclusively to only 2 characters. So in this case, it picks H and E. Those are 2 characters. Okay. So these are some of the operations you can perform on strings that at least you need to be aware of. You need to be aware about indexing, how the indexing works. So if you're moving from left to right, and also if you're moving from right to left, you also need to understand about slicing, right? Those are the basic things you need to be able to understand. Now, for example, let's start here. So, for example, we have if you have name, and then you say name is Lord, and then you say age, then you say age is 20, and then we say city, and then this is Nairobi. Okay, like this. And then somebody wants you to print something like this. So you need to print my name is Lord, comma, I am 20 years old and I live in Nairobi, like this. So how would we print this given given these variables here, right? Oops. Okay, that's an error because of this thing here. So to do that, we can print but I forgot to mention this about formatting. So there are ways in which format you can format strings, but we're going to talk about that later. So we can say something like this. We can say my name is and then of course we want to concatenate or combine strings. So my name is name. We're going to have name there, right? And then okay, my name is that. Uh, Another string here, we can say I am, and then we combine that. So you see how this one can be confusing sometimes. This is why these people decided to come up with what we call string formatting. We're going to look at it after struggling with this thing here. So so the age, I am age years old, and I think we can just put this one here, and I live in city, like that. There's an error, type error, cannot concatenate. Oh, okay. So this is a type error. You see, this is an integer. Age is an integer, but all these other values are string values. Okay, so it does not understand. There's no way you can mix, you can combine a string and an integer all together like that. That's the error there. So it means at age here, we need to convert it. We can type cursive, we can say string like this, then press enter. Now it says, my name is Lord, I am 20 years old. I think we should have put some space here, and I live in Nairobi, right? This is a way you can do to combine the strings. But now, when you do this, you realize we have to convert age into string. So this is where string formatting comes in handy. Let me clear this because it looks ugly. And then we start. So we have name is Lord. Age is 20. City was Nairobi. So with string formatting, there are two ways in which you can format a string. You can use F and then like this. So you have F and then quotation, all right? And then where we are going to have these variables, we are going to use curly braces. So we can say my name is, and then curly brace like this, and then you say name, okay? So my name is that. So this is going to be my name is Lord, right? Um, I am, okay, if I write this well, I am, and then age, right? So I am age, years old, and I live in city, right? So this is string formatting. We have F here, which is for formatting. Okay, this means basically you are trying to inform the print function that I need to print this string, but format it this way. Okay, so this one, if you press enter, it prints very well. Now you see this one does not throw the error of age is an integer, you cannot combine integer and string, blah blah blah, and all that, because the F here, the formatting, basically is able to detect that this is an integer. You're trying to combine it, and then it does everything under the hood. This is one way of printing formatted string. Another way is you can say print, and then uh, you can say my name is, and then we have the calibres. I am age, their age is going to be there, years old, and I live in city. Okay, sorry. I live in, like that. And then outside the quotation you say dot format, and then now you provide the the variables. So you have to provide them in the order in which you want them to appear. For example, if I say age here, age will be the first one. So it will be my name is age, and then I am like that, like that. So we need to start with name, comma, and then you go to age, and then you go to city, right? So if you press enter, it says my name is Lord, I'm 20 years old, and I live in Nairobi. Now, what if we change these things? Let's say this is the name, and then this is age. You see now it says my name is 20 and I am Lord years old and all that. So when you use the dot format, you have to be careful and keen on the how you arrange the variables. So, well, this depends on your preference. There are people who like to use the dot format, but there are people who just they prefer the F method here, where you just put an F and then you insert the variable names within the curly braces. So, well, for me, this one looks more simple and straightforward compared to the dot format method, where sometimes it can be a bit confusing. So basically that is that on that topic. I'm trying to move a bit faster because I want us to dwell mostly on these things that were disturbing people, that is functions and the likes. Now we also have some common string methods. Okay, there's some common built-in string methods, like for example, like upper. For example, in this case, we have name, right? If I print name and then I say dot upper like this, it's going to convert it into uppercase. All right. It does not matter, as long as you call dot upper, it will convert that particular string to uppercase. Or if you print, you can provide a name here and then say Velma, and then dot upper. You see, it returns an uppercase uh, uh, name. So dot upper basically uh, converts all characters to uppercase. We have dot lower, which converts all characters to lowercase. So if we say print and then we say Velma dot lower, it converts it to lowercase. We also have title, which capitalizes each word. So for example, if we have, you can say print, and then we say hello world. You see, everything is in lowercase, and then I say dot title. Now it capitalizes the first characters of each word. So the word hello, it will capitalize H, and then world, it will capitalize W. Um, which one again? We have dot strip. Yes, we have dot strip. So dot strip removes leading or trailing spaces. So trailing spaces, for example, if we have, let's say, we can say word equals to, and then you have space, hello. You see, like this. So we have this word here, but look at all these spaces like this. And then on this side also we have spaces. So if I say print, and then this is word uh, dot strip. Now it will print hello without all those very many spaces, right? So this is basically common again when you are collecting information from forms, okay? If you're collecting data from forms. There are people, maybe you told them to write your name and then they just press, they include a lot of spaces for no apparent reason. You see, when you're manipulating this information, you don't need those spaces. So basically you just strip the trailing all the blank spaces out so that you just remain with what you want. Okay. So those are some common string methods. These are not only them. I think there are very many, but at least these ones are the ones that have come into my mind right now. That is upper, lower, title, strip. Um, um, yes, there's also find, there's count, and all those. Okay, so there are very many. We talked about string concatenation and formatting. Mhm. Let me see. Yes. So there are these questions that I was trying to get from ChatGPT here, though they are not so great, but you can always practice them because programming needs practice all the time. So in this case, oops. So in this case, for example, the first question here, they are easy and they are, oh no, they are not there. We are on strings. Yeah. So create a string variable that stores your name and print it in uppercase. So what is wrong with this thing? Create a string variable that stores your name and prints it in uppercase. So for example, uh, why isn't it giving me the option to, yes. So you can create a string variable that stores your name and prints it in uppercase. So I can have name, then I can say equals to load like that. And then they want me to print it in uppercase. So I can say print, and then I can say name dot upper like this. Now if I run this cell, okay, why is it taking long? It's not connected. Okay, okay, connected. Yes, so now it prints the name in uppercase, right? Here given the word Python, print the first character and also the last character. Again, we talked about this. So oh God, why did I execute that? Yeah. So given the not here, not here, not here. Given the word, so the word is Python, right? They want us to print the first character, so we can print. So we print word at index 0, which is the first character, and then we should also print the last character, which is word at index -1. All right. So if you execute that again, so it prints P and N, right? So we have those questions. You can always use these ones for practice. Use slicing to extract the word world from hello world, right? Replace the word blue with green in the string. The sky is blue. So we have these ones. I have these a few questions. You can always practice these questions just, to better understand these things very well. I don't know why it keeps on jumping, but anyways. Okay. Anybody with any question up to that point? I want us to get into control structures.
I think Mariam had a question.
Mm-hmm.
Go back to your power. It's called PowerShell. Yeah, I don't know
Go back
the
to
name
my
that one.
PowerShell.
Yes.
Yeah.
Uh I think when you are where you are adding plus, where you had the edge, she was asking, does it work if you say plus then in quotes age?
Okay. Let me. So, for example, name was Lord and then age. Okay, let's just have these two. So like this.
Mhm.
So if I print um, name and then plus
In quotes age, parentheses.
inputs age like this.
Mariam, is that what you are asking?
Okay, I was just trying to explore the options. When you are concatenating the strings to form the sentence, my name is Lord Age, and then the age was an integer. I know there is the option of using the string function to convert it to a string to concatenate, but I was wondering if you put it in plus age in quotes, because I know also strings are also in quotes, does it work? I was just trying to explore if it works.
Oh, so for example, if I put in quotes like this.
Yeah,
Okay, now if you put it in quotes like this, instead of printing 20, it will print age like this.
age.
Yeah,
Okay, okay.
you see, loud
Thanks.
age. Yeah.
Yeah.
Any other question?
Anyone who has a question? We can continue.
Okay. Let us explore control structures. Control structures. Uh-huh. Now, what are control structures? So basically, you can say control structures, they allow programs to make decisions. You can say allow programs make decisions and repeat actions based on certain conditions. Repeat actions based on certain conditions. Okay. So basically when you're programming, you'll reach a point where you need to be able to make decisions. Okay. Maybe do I need to turn left or do I need to turn right? Do I need to display this or do I need to hide this? All right. Those are the kind of decisions you'll be making as you write your program. All right. Now, um, for you to be able to make the decisions, you have to use the control structures. Now, we have two main types of control structures. Okay. The first one, um, is we have conditional statements, and then the second one we have uh, loops. Okay. So conditional statements are used to execute. You can say they are used to execute different blocks of code depending on whether condition is true or false, right? Um, execute blocks of code uh, based on whether the condition is true or false, right? And then, okay, I think let's just start with conditional statements and then we're going to come to loops. Okay, so these ones are used to execute blocks of code based on whether a condition is true or false. It means you can have, maybe you have like 3 blocks of code, okay? But out of these 3 blocks of code, um, you just want the one that will satisfy your condition to be executed, okay? So in this case, you use a conditional statement. You say, maybe for example, if you say, if this is true, then I want you to execute this. But if it is not true, then don't execute it. Go to the next one, right? If that next one is the true one, then execute it. If not, go to the next one. So like that. So basically, your program is making decisions as it moves along the conditional statements. So the types of conditional statements that we have here are, the first one is we have the basic if statement, the basic if statement. So I think for this, maybe we can just open it here. No, let me create a folder on the desktop here. Let's call it practice. So practice, then let's move to the desktop and then move to practice. And then we open this on the Visual Studio Code. Yes, like that. So we can create a file, let's call it main.py. So this is where we are going to do all our shenanigans. So the first one is the basic if statement. So the syntax for if statement is you can have if and then you have a condition, okay, full colon, and then here is now you can say code to execute, right? Um, yes, let me put it inside the comments like that. So this is how there may be up here. We can have a comment that says basic if statement. So this is the syntax for an if statement. So you have the keyword if, and then you have the condition, okay, and then you have the code that you need to execute. So the code will execute based on the condition here. All right. If this condition is true, then the code here is going to be executed. All right. But if the condition here is not true, meaning if it is false, then the condition is not going to be, the code is not going to be executed. The most common example is, let's say we have age, and we say age is maybe 17, right? We all know that, okay, in most countries, people who are 18 and above are the ones who are eligible for voting, right? So we can use a conditional statement, which in this case is the basic if statement, to check if it is true that a person is able to vote, right? So you can say that if the age of this person is greater than or equal to 18 years, maybe you can tell them you are eligible to vote, or maybe you are an adult, right? So an example can be if, you can say if, and then we provide the condition. So the condition in this case is age greater than or equals to 18. Okay, if age is greater than or is equal to 18, and then now we want to print you are an adult, like this, right? So in this case, we have the variable age. We have given it a number. You can give it any number that you want, right? And then we are basically checking if the number that has been provided there is greater than or equal to 18. Okay, I think what we can do, instead of encoding this number, we want the user to be the one to input the number. So the user will be inserting their age, and then we'll be telling them whether they are adults or not. So we can use the input method, input, and then we can say age, like this. And then, oh, okay, like that. So the user will enter their age, will prompt them to enter their age, and then we'll check if the age is greater than or equals to 18, and then we'll tell them whether they are adults or not. So let's open the terminal here and let's execute this code. Yeah. So Python main.py. Yes, now it's asking for age. Enter your age. So let's start with 12. So 12, type error. Oh, okay. Okay. Now this is what I was talking about. You remember? If most of the time when you're collecting data from people, the data will come as a string. So you see, this is giving us a type error. You need to be able to understand the types of errors you're getting, and then you'll be able to resolve them just immediately. So this is a type error, and then it says not supported between instances of string and integer. So it means when the user enters their age here, it comes as a string. Okay, it comes as a string. Actually, let's just try here, print, and then type of age. Let's comment this one below here so that we can see. So let's run that one again and then enter 12. You see, it's a string, right? So that means for this code to run, we need to convert that string into an integer, then we compare. So we can actually wrap all these like these ints, like that. So it means immediately it has been typed, it's being converted to an integer directly. So that's that. So now let's run this. So we test 12, and then if you press enter, you see it's not giving us anything. Why? Because age is not greater than or equals to 18. All right. Okay. Let's run it again and give it a number like 30. Now, if you enter 30, it says you're an adult. Okay. These are basic if. So if statements, they basically just check one condition. Okay. In this case, what it's checking is it's checking if age is greater than or equal to 18. If it is true, then it tells us that we are an adult. If it is not true, it does not tell us anything because we have not asked it to tell us anything, right? Now, let's add something. Let's say else, okay? And then you say print, you are still young, like this. So here we are adding another condition. Now we have two conditions, okay? I mean, now we have, okay, the condition is still one, but the output is going to be based on whether the condition is true or false. Okay, so if the condition is true, it's going to execute just this upper part like this. If age is greater than or equals to 18, if it is true, the program is going to execute this, and then it will not touch this part. This lower part will not be touched, right? But if the upper part is not true, then it's going to skip it, and then it's going to come to this lower part, right? Now, let's rerun the program again. Now let's pass the value 12. Now you see it saying you're still young, right? So it found out that the condition is not true. So it skipped this one and then it went to this other one, right? So it's checking one condition, but based on whether the condition is true or false, it will check for the block of code to execute, and then that block is what will get executed, right? So this is if and else at the same time. The first one where we did not have the else part is if, okay, the basic if. Now when it's like this, this is else if statement, right? So if else also, the syntax is just you have if and then you have a condition like this, and then this will be the code to execute, and then you also have an else with code to execute like this, right? So that's the same thing we have here, right? So we have if statement, we have if else, and then we have if elif else like this, yes. So the syntax is if and then you have a condition like this, okay? So this will be like condition one, right? If this condition one is true, then code to execute like this. Elif, which basically means else if, and then you can have condition two here, and then with the code to execute, right? And then we have the last one, which is else, and then with the code to execute. For example, yes, let me comment this one out so that we will not get many errors. So let's say we have marks like this. So we want students to give us their marks, and then with the marks, we'll be able to determine the kind of grade they get. So we can have marks, and then we want to convert it to integer, then input, and we can say enter your marks like this, right? So we have marks, and then we want to check if marks is greater than or equals to 80 like this. We can, let's print grade. I think this is grade A. Yes, grade A like that. So that's the first condition. It checks if the max is greater than or equals to 80. We want to chain along many of these elif conditions. So another one you can say elif. This is the second condition. You can say if max is greater than or equals to, maybe we can put here 60, and then print. This is grade B. Um, Maybe we can say if max is greater than or equals, I think this one you can put 40, and then you can say print. This is grade C, like that. Okay, now getting below this is being bad. So we can also put else, and then we say print, and then this one you can say grade fail like this. When you have this kind of thing, you can insert as many elif statements in between as possible. So we had not tested this. So enter your marks. Let's start with let's try 30 first of all. Then 30 and then press enter. So you see grade fail. So 30 is not part of all these. So that is why it tells us that this person has failed, right? And now if we try, let me give it some space. If we try, let's enter 90, then press enter. So grade is A. So that person has a grade of A. What if let's try 120? Though these are conditions we are not factored in, right? Maybe we should put a threshold because you can't have 120 marks. It does not make sense. But maybe that is something we can work on later. But you can see any mark that is greater than or equals to 80 is considered as A. So it will check the marks, right? And then it will evaluate it on each and every block. Okay, so the first block is it checks if the mark in this case is 120 is greater than or equals to 80. So that's why it prints A, because it will just check the first instance. If it is true, then execution stops there, and then it just gives us an output, right? If it was 30, it checked all these conditions, but none was befitting 30. So that's why it had to come to the else part, right? Now, we also have nested if statements. Okay, we have nested if statements.
Lord,
Yes,
before you go on, it's just a question.
yes.
It doesn't spelling does not affect the result, right? Okay. That was
Spelling
the
is in terms
question
of.
because I can see here
Oh, yeah,
where
yeah,
you've
yeah.
written enter your marks.
Okay. Uh, right. Okay, so
I
you
don't know
see,
if I'm the one seeing that.
yeah, I've just seen
You
this is
see on
supposed to
your,
be
yeah,
marks. Yeah. But okay, you see why this is not getting affected is because this is enclosed, it's a string. So it's just being displayed. Okay. When you write, when you run the code, this is just getting displayed here. So that's why it's not throwing us any error. Python, as long as everything is working well, its work is not to check if you have spelled things correctly, all right? But I think for purposes of clarity, you just need to spell everything right. Okay.
okay, thank you. This Paul has raised his hand.
Mm-hmm.
Hello.
Yes.
Hi, Paul.
Yeah, hi. I have a question on uh, the if marks that one is greater than or equal to 80, right?
Yes.
Yes. I'm just wondering. Let's say there is maybe a number that is above 80. How does it grade?
Yes. So, okay, a number that is above 8 is going to be executed here. So, for example, you see here I entered 120. This one was also 90. So all these numbers are greater than 80, right? So they befit this condition, all right? 90 is of course greater than 80. 120 is also greater than 80. So it means it's this block that is going to be executed. Basically, as long as the number is greater than 80,
There is a limit, right?
a limit to,
The number is greater than or equal to 80, right?
yeah.
So any number that is any number that is above 80, it will print. grade A, right?
Yes, as long as the number is more than 80, or if it is 80, it will print A. So it will print A starting from 80 going up.
Yeah, now I get you. I get you. I
Okay.
get you. Okay.
Uh-huh. So that is that. Now the next one is we also have nested if statements. So sometimes you can place one if statement inside another, right? This is what we call nesting. So you have the outer if statement, and then you have another one inside it, right? So for example, okay, I think we can use an example of, let's say, age equals to int input, and then enter your age. And then maybe you can say citizen equals, and then input, you can say where are you from, like this. So we can say if age is greater than or equals 18, right? So if age is greater than or equal 18, and then inside this if statement, we can have another if statement. We can say if citizen is equals to, let's say, Kenya, like this. Maybe we can print what can you say? Okay, you can say you are a Kenyan and are eligible to vote, like this. Maybe we can add an else here and then say else print what can you say? You must be a citizen of Kenya to vote in Kenya, like that. And then else you can say you're too young to worry about voting and citizenship. Yeah, like this. So in this case, we have this if statement here, this outer if with the and then you also have its else part here. And then inside this if statement, we also have another block here, another condition here. So what does this do? So it takes the age. So it first checks if the age is greater than or equals to 18. All right. So, okay, this is the nested if, because we have the outer if and then we have another if inside the outer if. Okay. So the way this thing executes is like this. It checks for the outer condition first. So is age greater than or equals to 18? If this condition is true, then it will go inside to execute, because now this is the code it's supposed to execute inside this first block. So if it's true, it again comes here to check if the citizenship is Kenya. So it will check if the value that has been inserted here is Kenya. If it is Kenya, then it will print this, right? If it is not Kenya, then it will print this other part, right? Okay, what if the age is not greater than or equals to 18? then it will not execute anything within the first block here. It will just come to the else part here and then return or print this one. So let's test it out. Python main.py. Now enter your age. Let's start with 20. Citizenship. Let's be correct on everything first. So you see, you are a Kenyan and are eligible to vote. So this one, right? Because the first condition is true, that is why it went inside this condition. And then it checks here, this condition is also true, and then it prints here, and then it stops. It does not execute this, it does not execute the rest, right? Now, let's give in a age 10. Where are you from? Let's say Kenya. You are too young to worry about voting and citizenship. So you see, what it did is these ones are just executed normally, but the conditioning here, age is already less than or equals to 18. So it means this condition is not true. So it does not bother to check inside here to execute whatever is inside here. It skips it. It goes to the else part, and then it tells us we are too young to worry about voting and citizenship, right? Let's say age is maybe 24, and then citizenship, let's say um Tanzania. So you see, you must be a citizen of Kenya to vote in Kenya. So age, this condition is true, right? That is why it came inside here. But when it came inside here, it found out that this condition is false. So that is why it skips this block and then it executes this next block, right? I hope that one is now understood. Now, another thing about these conditional statements is indentation. Always watch out on your indentation, right? With Python, we have this full colon here, okay? So everything inside, you see, basically the this text editor is able to detect that there is a full colon here. So if you press enter, it automatically indents 4 spaces. So it means everything here belongs to this first block, right? So this if and the else part belongs to the first block, right? And then this one belongs to the second block. So if this one comes out like this, you see already there are some red squiggly lines here to indicate that there's some error somewhere. If you hover over this, it says expected indented block, right? So it means it expects indentation. Okay, now that is conditional statements. We also have loops. Okay, let me pull out where I was writing notes. So we talked about basic if statements. We've also talked about if and else. Okay, I don't know what's happening there. And then we've talked about if, elif, and else. So those are the main ones, right? So that is conditional statements. Now we also have loops. Now we've said conditional statements, they execute block of code based on whether condition is true or false, right? Now what about loops? Now loops, they basically let us be able to repeat tasks automatically. Okay, so it means instead of writing same code multiple times, basically you can use loop to repeat that task. Okay, so you can say that they help you repeat tasks automatically instead of writing the same code multiple times. Okay, the two main types of loops we have are for loop, and then we also have while loops. Okay, now for loops are used when you want to repeat something specific number of times. Okay, when repeating something specific number of times, you want to repeat these 5 times, all right? You want to do these 10 times. Okay, so the syntax for loops, I think we can now do that, and then for loops. So the syntax for loops is like this. So you have for, and then we have a variable, and then in, and then you can have a sequence like that, and then here you can have the code block or the code to execute. For example, the most basic example is, let's say you want to print maybe numbers from 0 to 4. All right, so you see we want to repeat these tasks, and on every iteration we are printing a number. You can decide to say print and then 0, and then you go to the next line, print 1, next line, print 2, like that. It's very possible. What if you wanted to print 100 of them? Now that becomes tiresome. So that is why loops come in handy, right? So in simple terms, you can just say for I in range, and then you can say 5, right? Then you can say print I, just like that. So in this case, if we now run our main.py, it prints from 0 all the way to 4. Okay, now here we are using the range. Okay, so range means it will want the starting point of the start value and the ending point. If you don't provide the starting point, it starts at a default of 0, right? And then we are telling it to print in a range of 5. So these are 5 values: 1, 2, 3, 4, 5, right? It's just that it started at 0 and then it went to 1. So basically what it does is, for I in range of 5, so it checks, it will start with I equals to 0, right? So it will start with I is 0. Okay, so 0 is still within the range of 5, it prints 0, and then it goes to 1. 1 is still in the range of 5, like that, up to the last one. Okay, we can also do it like this. You can say for I in range, let's say from 2, and then the last value you can say is 10. Okay, so now this one, if we run it, you see it starts at 2, right? It starts at 2, and then it goes up all the way up to, it prints up to 9. So it will never print the last value here, 10. Okay, it will always print it -1. So it means if you wanted to print 2 to 10, this one will have to be 11, right? If it's 11, now it prints 2 all the way up to 10. All right. You can also print, let's say, letters. Okay, so we can say for letter in okay, for letter in maybe Python, like this. Okay, and then we say print letter. So this one, what it does is it will print each and every letter of this word Python. So it starts with Python, like that, right? Okay, that is that. This one is not so much complicated, but we are going to do some more examples in the exercises. Now, that is a for loop, a while loop. Now, a while loop will repeat a block of code as long as a condition is true. Okay, as long as the condition is true, it will keep on repeating that particular block of code. That means if the condition turns to false, then it stops repeating that code execution. One thing you have to know about while loops is that, remember, it's printing as long as the condition is true. So it means if there's no mechanism that will turn the condition back to false, that thing will print or will execute forever. Okay, so it means when you're using a while loop, at some point you will want to ensure the condition at least reverses and turns to false, unless you want to print it forever. For example, if you are printing 10, um, uh, so it means it will print 10 as long as the condition is. So maybe you're printing, okay, let's just get into the example so that you can see my talk and give the wrong things. So the syntax for a while loop is like this. So you'll say while, and then you have a condition, okay, and then here is the code block, or the code to execute. So for example, we can say okay, let's use the same example for counting number, for printing numbers. So you can say while let's say number is less than or equals to, okay, let's just use 5, like this, and then you say print number, like this. Okay, so it means we have to provide the first value of number. So you can say number is, maybe it starts at 0. Okay, so what this thing does is it checks, is number less than or equals to 5? It will print the number. Okay, now after printing the number, what next? We can say number plus equals 1. So we want it to keep on adding. Okay, because if we don't do this, it will just keep on printing 0, 0, and there is no any point that 0 will turn to be greater than or equals to, will turn to be greater than 5. Okay, so it means if you don't add this line, it seems this thing is going to print forever. Okay, let's actually test and see. You see, it's just printing zeros. It starts printing zeros. So I actually have to cancel it. Okay, look at all the zeros it has printed. So this is why I'm telling you, for while loops, you have to be careful, because it will always just keep on printing as long as the condition is true. This condition will forever be true because there's no way it can turn into false. So that's why it continues printing 0. You see, I'm scrolling and it's still zeros, right? It's still zeros. So you need to have a way of ensuring the condition turns to false. So here I have to add number plus equals to 1. So what it does is the first number will be 0, right? And then it comes to check, is 0 less than or equals to 5? Yeah, it's true. 0 is less than or equals to 5. So print it. It prints 0. And then 0 plus equals to 1. It means it adds 1 to 0. Now 1 is the number. And then it checks, is 1 less than or equals to 5? Yes, 1 is less than 5. So it prints that 1. After printing 1, it adds another 1 to 1. Now it's 2, right? So it will keep on doing that until it reaches 5. So if it reaches 5, it will find that 5 is actually equals to 5. So it will print 5 and then it adds 1. So if it adds 1 to 5, it will be 6. Is 6 less than or equals to 5? No, it's not. So the condition now turns to false and then it stops there, right? So this one, if we run it, oh, okay, I need to comment this one out. Let me comment this one out like this. Now, if we run this one, you can see it prints 0 all the way up to 5. But now when it reaches to 6, the condition has now turned to false. So the program stops there, right? So be careful with while loops. There are some situations where, okay, most of the things that while loop does, even a for loop can do them. So that's why, okay, most people use for loops. But there are situations where whatever you are doing, maybe using a while loop is what will give you the best outcome. So you have no choice. But then when you're using a while loop, be careful that conditions should always at least turn into false, right? So that it prevents that issue of um of having an infinite loop. Now we also have loop control statements. All right, we have loop control statements. Loop control statements. So these are commands that change how loops behave. Okay, there are commands that do change how loops behave. The first one we have is break. Okay, so breaks basically they exit the loop completely. They exit the loop completely. Let's look at an example. Look at these. We're going to do some few exercises. So, for example, let's say okay, let's say, for example, if I say for number in range, maybe let's say 1 to 10, and then I can say if number is equals to, let's use 5, right? Break, and then print number. So what is this thing going to do? This thing is going to check the number. So it will start, of course it's arranged, so it starts at 1. Okay, so it will print 1 and then it checks, is 1 equal to 5? No, it's not equal to 5. So it continues printing. It goes to 2, it checks. So it means when it reaches a point where the number is now 5, this condition will be true, right? So since 5 is equal to 5, it breaks, right? So it means it will not print that 5. This because it will execute this code and then inside this condition here, there's a break. So break basically exits that loop. So it means it's like execution was going on just well, but then it reaches a point where it just terminates, right? That is what break does. That is what break does. So inside this if statement, as long as the condition of if statement here is true, the execution is just going to be terminated like that, right? So this one, if we run it, I think it's going to print 1 up to 4. Yes. So it prints 1 up to 4. Why is it printing 1 up to 4? Because 5 is actually equal to 5 and it's not going to print. You realize the print is after the if statement. Okay, so it's going to, it's supposed to print after this condition. So it means all these numbers that have been printed, they were not satisfying the condition. That is why the condition was being skipped. So it will skip, for example, if it's 1, 1 is not equal to 5. So the condition is not executed, it's skipped, and then it comes here to print that number. Okay. Um, the second one is is break, not break, continue. Now, continue skips the current iteration and moves to the next one. Where is the notepad? Continue. So skips the current iteration and moves to the next one. Okay. So let's go back to example here. So for example, I think we can just use this. So let's change this one to continue, right? So if we change it into continue and then we run it now look at what it does. It prints 1, 2, 3, 4. It skips 5. It goes to 6, 7, 8, 9. So continue, we've said it skips the current iteration and moves to the next. So it means it will check the condition. Okay. If it reaches 5, okay, this iteration will keep on printing. So it will start printing at 1, at 2, 3, 4. But then when it comes to 5, 5 is equals to 5. So it means this if condition is true. So what does it do? It skips it, continue, jump it, right? So if if the number is equals to 5, if that condition is true, jump that number, don't print it, and then just continue to the next one. That is what continue does, right? And then the last one that we have is pass. Pass. Okay, I won't really argue that. Okay, pass is just not for loops, even for functions, right? Because pass is just like a placeholder. A placeholder, it means just do nothing, right? So you can create a function, but then you still don't have the block of code inside that function that's supposed to do something. So to prevent errors and all that, you can just um, have pass inside there. For example, in this case, if we put pass here, that one like this, so you can see within this for loop, we just have pass here. So it means there's nothing that this loop is doing. Okay, there is no code inside it. But because we don't want errors, because let's say if we just leave it like this, you can see there's an error here. It means it expects something inside um uh this for loop block, right? But if we just have pass, it just basically telling Python, you see, I have this for loop, but at the moment I don't have anything to write into it. So just pass it and just execute the next code that follows, right? And it will do so. Okay, so let's come back here. Reconnect. A program that checks whether a number is positive, negative, or zero using if, elif, and all that. So we can have a number Or we can let a user input a number. So we can say number equals input and then enter random number. And then we can use the if to check whether number is positive, negative, or 0. How do we check if a number is positive? So you can say if number is greater than 0. That means it's positive, right? Because numbers that are less than 0 are negative numbers, -1, negative, all that. So if number is greater than, we can actually put greater than or equals to 0, I think, yeah. Greater than or equals to 0, then we can print uh, number is a positive number. And if number is no, this one is supposed to be greater than 0, just greater than. If number is less than 0, print f, and then number is a negative number. Then you can say else is a 0, like this.
Null
Yes,
is null.
sorry.
Else prints number is null.
Okay, let me just put there. So let's run that. Let's start with 20. So 20 is a positive number. Let's start with, let's try negative 10. So negative 10 is a negative number. But then if we put 0, it will do that, right? So you can see we're basically using the if or if and all that. Now, the next one is write a program that prints all numbers from 1 to 10. So this one again we can use for loop. So we can say for number in range. So they want 1 up to 10. So we can say in range 1 to 11, and then you can say print number like that. So if we run that, it will print 1 up to 10. Print learning Python 3 times using a loop. So that one you can do. Okay, so I have easy ones here. There are 5, and then we also have some hard